Good morning, children. So today we discuss about the gravitation. आज का chapter gravitation है. So in this gravitation, you know ना, so Newton's universal law of gravitation. That कहानी मालूम है आपको. So Newton apple गिर गया. So why the apple comes towards the surface of Earth? Why it is not going up? And suppose if you project a body upwards, why it comes towards the surface of Earth? So all these things, experimental verifications. So Newton concluded that so there is a force of attraction. That force is acting towards the surface. Before Newton, so many people observe these things, and finally by those results, Newton concluding that he developed one law, that is Newton's universal law of gravitation. Newton's universal law of gravitation. Newton universal law of gravitation. So according to that Newton, that force between two bodies, if you can take two bodies of mass m1 and another body of mass m2, and these two bodies separated by a distance r. This force is attractive force, and this attractional force is directly proportional to product of their masses m1 and m2, and this force is inversely proportional to square of the distance. If you go for higher classes, this distance f, why it is inversely proportional to r square, why it is not inversely proportional to r. So for that we discuss in higher classes, sir. So that is, we calculate that centripetal acceleration and acceleration due to earth, and ratio we can take, and thereafter radius of that circular orbit and radius of the earth. By taking those relations, finally we conclude that force is inversely proportional to r square. So itna extension आपको नहीं चाहिए. So only that force of attraction between the two bodies is directly proportional to product of their masses and inversely proportional to square of the distance. If you combine these two forces, these two relations, if you write F directly proportional to m1 m2 by r square. If you remove that proportionality, we multiply with some constant, that is we represented with capital G m1 m2 by r square. ठीक है. So this is Newton's universal law of gravitation. ठीक है. Means according to Newton, the force of attraction between the two bodies directly proportional to product of their masses and inversely proportional to square of the distance between the two masses. Means if size of the masses, that is masses increases, force is also increase, and distance between the two masses increases, force decreases. F is inversely proportional to r square. So final expression F equals to capital G m1 m2 by r square. Here capital G we call universal gravitational constant. So capital G is universal gravitational constant. universal gravitational constant. Means entire the universe का value remains constant. So capital G is value 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is the value, this value remains constant entire the universe, that is 6.67 into 10 to the power minus 11. This value remains constant. So come to that dimensional formula of this capital G. So dimensional formula of capital G. So what is the dimensional formula? So dimensional formula के लिए by using this relation, a relation लेके हम dimensional formula लिख सकता है. So G equals to F into R square by M1 M2. So from that second chapter, units and dimensions, you know that dimension formulas, how to write the dimensional formulas. So by using that dimensional expressions, force का dimension मालूम है आपको, M L T minus 2. Force is nothing but product of mass and acceleration, M L T minus 2. And R is nothing but a distance. Distance को we represent with letter L है ना. So divide masses m into m. So 1m cancel हो जाएगा. So G equals to क्या आ जाएगा? M goes to the top, numerator m minus 1. So m minus 1 आ जाएगा. And L square into L, L cube. T power minus 2. So this is the dimensions of universal gravitational constant. This is also very important for JEE Main and as well as NEET. Aajkal they are asking that questions based on units and dimensions. Match the following questions also there. In that match the following, they are given some physical quantities in left side and other side they are giving the dimensional formulas and match it. So that's why in that cases these constants ka dimensions are very important. So those dimensions, just if you remember the formula, based on that formula, basic quantities ka dimensional formulas if you know, then easily we can develop that dimensional formula. So आजकल NEET में question आ जाएगा and as well as in JEE में वो क्वेश्चन आने के लिए चांसेस ज़्यादा है based on dimensions. In advance also they can prepare one question from this units and dimension chapter. So means dimension formulas का importance ज़्यादा है. So that's why you must remember this one. ठीक है? This is dimensions of capital G, sir. Now the expression for force, this one, this force in vector form. How you can write this force in vector form? Vector form of gravitational force. So vector form of gravitational force, simply we can write F bar equals to G m1 m2 by r square into r cap. G m1 m2 by r square into r cap. So r cap is unit vector. It gives that direction. This is the vector form of that gravitational force, sir. Vector form of gravitational force is F bar equals to G m1 m2 by r square into r cap. R cap is the unit vector. Unit vector. If you see here, this gravitational force is an attractive force. M1 attracted by M2. M2 is attracted by M1. So, force acting on M1. So, due to M2. means force on that force on first particle, first mass due to second F12. So this is attractive force. So M2 is attracted M1 towards that, and M1 is attracted M2 along this direction. That is force on second particle, force on second body due to first, that is acting in this direction. So these two forces are attractive forces and they are acting in opposite direction. So here if you develop some properties of this gravitational force. So what are the properties of the gravitational force? If you go for that next sheet, properties of gravitational forces. Properties of gravitational force. Properties of gravitational force. So, two bodies if you can take, a body of mass m1 and another body of mass m2. They are separated by a distance r. Then this body is attracted by second mass, that is force on 1 due to 2, and m1 is attracted by m2 is attracted by m1, that is force on second due to first. So here the gravitational force. Gravitational force is an attractive force. This is the first property. Gravitational force is an attractive force. It is an attractive force. Second, so gravitational force is only attractive force, sir. इसमें there is no repulsion. So always the two bodies in the universe attract each other. So that is attractive force. Second, these forces, gravitational forces, if you can take these two forces, they are action and reactional forces. Action, reaction pair. So F12 is equals to minus F21. These two forces are action and reaction. ठीक है, these two are equal in magnitude but they are in opposite direction. And if you go for the next one, these forces are acting along the line joining between the two masses. These forces acting are this force acting along the line joining. This force is acting along the line joining between the masses. Line joining between the masses. So this force is not acting like this or like this, sir. It is acting along the line joining between the masses. So this is acting along the line joining between the masses, and this force is central force. This force is central force. Means F is inversely proportional to R square. So it is a central force. It acts center to center, sir. ठीक है? And fifth, if you can take This force is valid for point masses. This force is valid for point masses. This force is valid for point masses. So, only for point masses this gravitational force is valid. But in universe, there is a force of attraction between Earth and Sun, Earth and Moon. So for that, that is heavily bodies. So for that heavily bodies also this force is valid. Normally gravitational force बोलता है ना, gravitational force of attraction between Earth and Moon. How? So you know the formula, F equals to G m1 m2 by r square. When compared to that masses of the two bodies, Earth and Moon, this distance is too much. If distance is too much, then the two bodies acts like a point objects. The two bodies acts like a point objects. So because Earth and Moon distance is too greater, so that's why if distance is too greater when compared to their masses, then the force that the two bodies consider as a point objects. If you observe from this surface of the sun and you observe the moon, that moon appears like a point. Moon appears like a point because of that distance. That's why that force is applicable for large bodies also, but if that comparative distance is too much greater when compared to their masses, then this formula is valid. ठीक है? So formula is valid for point masses. Formula is valid for point masses. When compared to their masses, the distance of separation between the two bodies are too greater, then that bodies are considered as a point objects and we calculate the gravitational force between the two bodies. ठीक है? So these are the properties of gravitational force. These are the properties of gravitational force. Basic properties of gravitational force. Okay? So by using these gravitational forces, we can do some numericals based on this concept. So you know the formula. Basic thing is that formula. So the formula is important. F is equals to G m1 m2 by r square. This is the formula. This formula is important. Based on this formula, if you develop the relation, force is directly proportional to product of the masses m1 m2. Means F1 by F2 if you can write. So m1 m2 by the new masses m1 dash m2 dash. So force ratio, if distance of separation between the two bodies remains same, then force is directly proportional to masses. If the masses are remain same, force is inversely proportional to r square. This formula also we can use. F1 by F2 comparison में R2 by R1 whole square. If distance of separation between the bodies are change but masses of the bodies remain same, then we can use this formula. And one more important thing, property में, this gravitational force is independent upon, this force is independent upon medium, independent upon medium present between the two bodies, present between the two bodies. ठीक है? So this force is independent upon the medium present between the two bodies, sir. So if the two bodies, if you kept in air, or the two bodies if you kept in water, in both the cases that force remains same. It doesn't depends upon, because in the formula if you see that G, this G is constant. इसका वैल्यू मालूम है आपको? दैट वैल्यू रिमेन्स कांस्टेंट 6.67 into 10 to the power minus 11. This value is constant entire the universe. If it is constant entire the universe, so this is constant, mass is constant, distance be constant, then force always remains constant. ठीक है? So gravitational force doesn't depends upon the medium. Doesn't depends upon the medium. If you calculate the force between the two bodies in air, a particular distance of separation, say 1 meter, you got 10 Newton. The same two bodies, if you kept in water or oil, whatever the medium between them, so then the separation of distance is 1 meter and you maintain the same distance, same masses, बीच में medium is oil or water, whatever the medium you take. So that medium if you kept, so then the force doesn't alter. The force doesn't alter. So that you must remember this gravitational force, because in class 12 same concepts we discuss in electrostatics. So there little bit different हो जाएगा. Formula सब same है, but थोड़ा difference हो जाएगा. There force is depends upon the medium, but here the force is doesn't depends upon the medium. That you must remember, sir. ठीक है? And one more doubt if you have. So normally, sir, if two objects are there, normally if you can take a pen and this board, or pen and that camera, so दोनों का बीच में force of attraction is there. So why this pen is not stick onto that body? So this is a doubt, general doubt. So suppose that two bodies of masses, for our convenience, these two bodies are there, na? This body mass say 1 kg, this body mass say 1 kg. The separation is, for our convenience, if you can take 1 meter. For our convenience, if you can take 1 meter, then force how much? 6.67 into 10 to the power minus 11. Mass 1 into 1, distance 1 square. So then how much gravitational force is comes? 6.67 into 10 to the power minus 11 newtons. This force is nothing but 6.67 divided by 10 to the power 11. Divided by 10 to the power 11. So 10 to the power 11, sir. Means it is very very small, 0.000067 ऐसे लिखना पड़ेगा. So it is very very small. That's why almost negligible force. That's why there is no attraction between the two smaller objects. This force is considerable for heavily objects. This force is considerable for heavily objects. So एक earth, if you can take, एक ball is dropped from here. So there is a force. ठीक है? So that ball comes towards the earth. So that force is considerable. Earth and moon, their masses are heavy objects है ना? So their masses are heavy when compared to that mass of earth. If you can take, that is in power 10 power of 24, order of 10 power 24, ऐसे हो जाएगा. So in those cases that force is considerable. So for small objects this force is not considerable, sir. Means very very small. So gravitational force comes very, very small for smaller objects. That's why these smaller objects doesn't attract each other. So heavily objects, if you can take, huge mass is there. So Earth, Moon system, Earth, Sun system, if you consider, so those forces are considerable forces हो सकता है. ठीक है. So this is about Newton's universal law of gravitation, sir. Newton's universal law of gravitation. इसका base some numericals, if you can see this. First numerical, if two particles each of mass m are placed at the two vertices of an equilateral triangle of side A, then the resultant gravitational force on mass m placed at the third vertex is, means we are taken equilateral triangle, sir. Equilateral triangle. Equilateral triangle. ठीक है. This is an equilateral triangle. On this equilateral triangle, we kept two masses at the two corners. We kept two masses at the two corners. इधर एक मास, इधर एक मास. ठीक है. Equilateral triangle means sides are same. Suppose A. Third mass we kept at the third vertex. ठीक है. So here this mass m and this mass is m and here also m. This is the third mass at third vertex. Suppose we calculate that effective force. This mass attract this one in this direction. This is one force. And this mass also attract this one in this direction. This is another force. And these two forces, if it is an equilateral triangle, angle kitna sir? 60 degrees. This is also 60 and this is also 60. It means these two forces making an angle 60 degrees. This force and this force on this third particle making an angle 60 degrees. Distance is same, particle masses are same, therefore force is also same. So what is the formula for force? You know na, vectors. So the starting chapter mein kinematics mein vector chapter already we discuss. In that parallelogram law of vector addition. So according to that parallelogram law of vector addition, there is a resultant force. So what is the resultant force? Fr equals to F1 square plus F2 square plus 2F1 F2 cos theta. So this is the force. Fr is equals to root F1 square plus F2 square plus 2F1 F2 cos theta. This is a resultant formula. If force is a vector, that's why we can use that vector algebra. Based on that vector algebra, under root F1 square F, F2 square F, so F square plus F square plus 2F square cos theta. So under root F square plus F square is 2F square. This is also 2F square. So theta. So what is the angle theta? Theta is how much? 60 degrees. If you take 60 degrees, cos 60 value 1 by 2. So 2F square cos 60 degrees is 1 by 2. This is 2F square. Cos 60 is 1 by 2. 2 cancel. हमको कितना मिला? So root 3 F. Root 3 F. So what is F value from here? F equals to G m into m square by a square. This is the force. So you replace with F root 3 G m square by a square. So this is the resultant force on any one of the vertex. We are taken that third vertex. So in that third vertex, the force is root 3 G m square by a square, sir. So this is the force acting on that. So simple formula F equals to G m square by a square we can use, and we can apply that vector algebra formula, that is in vectors resultant force we calculate. That force finally we can calculate. Now if you see this second question, so if you pause the video and you can solve this, easily you can solve. Here, if four identical particles, each of mass m, are kept at the four vertices of a square of side length a, so the gravitational force of attraction on any one of the particle is. Simple question hai. So easily we can solve this. Square. These questions in आजकल JEE में आता है, NEET में भी आता है ये questions. So that's why simple question. Four particles, all are identical, having masses m, m, m. Any one of the corner, they can ask any one of the corner, you select and you calculate the net force on that particular particle. Suppose if you select this particle, okay? So if you select this particle is attract this one in this direction. This is a square, means all sides are having equal length. All masses also identical. So this mass attract this one with a force F. This mass also attract this one with a force F. Two forces complete. Third particle. ये पार्टिकल देखो, ये पार्टिकल क्या करेगा, इसको अट्रैक्ट करेगा. कौन सा डायरेक्शन में? ए डायरेक्शन में अट्रैक्ट करेगा. ए मास का डिस्टेंस कितना है? ए. इधर ए दोनों का मासेस में डिस्टेंस कितना है? ए. मीन्स इधर फोर्स सेम है, बट ए मास एंड ए मास, ये दोनों का बीच में डिस्टेंस according to Pythagoras theorem, this is side A, this is side A, this is the hypotenuse. So पूरा A distance कितना हो जाएगा? रूट 2A. So distance अलग आया. If distance is अलग है तो force भी अलग होता है, because F equals to G m1 m2 by r square. Maybe mass is same, but distance is different in this case. That's why force is different. So that force, if you represented as F dash, that force if you represented as F dash, and these two forces का resultant along this direction it acts, that is say Fr. Therefore, net force is equals to, ये दोनों forces same direction है ना, so F resultant plus F dash. It means this force and this force. What is the angle between these two? 90 degrees है ना. So how you calculate Fr, sir? Fr. Same formula, sir. F1 square by practice directly भी लिख सकता है F2 square plus 2F1 F2 cos theta. So under root F1 square is F square, F2 is F square plus 2F into F square cos 90 degrees. Between these two forces, angle is how much? 90 degrees. Cos 90 value 0. Cos 90 value 0, then root F square plus F square क्या आ जाएगा? Root 2F आ जाएगा. This is FR. What about F dash? F dash equals to simple G m into m square by distance is root 2a whole square. So root 2a whole square, this is the distance between the two masses. So root 2a whole square. So then net force F net is equals to root 2 into F. F means F value कितना सर? G m into m square by distance is a square. So F value G m square by a square plus F dash value. F dash value कितना कैलकुलेट किया? G m square by root 2a whole square. Root 2 whole square means 2a square. इसको further simplification, if you see here, further simplification, F net is equals to G m square by a square, common ले लो. G m square by a square is common, then root 2 plus 1 by 2 आ जाएगा. Root 2 इधर remaining, इधर 1 by 2. Then F net equals to G m square by a square. If you take LCM or ऐसे भी रख सकते हैं ना. So 2 root 2 plus 1 by 2. So this is the force on that any one of the corner in a square. Means simple. So any one of the corner you select, due to the remaining masses, you identify the direction of forces. That forces is always attractive force. Here if you can take this mass we consider. So this mass attracted in this direction. This mass also attracted in this direction. In these two cases, forces are same because either masses same, distance also same. Either mass be same and distance also same. So forces are equal. But these two forces are in mutually perpendicular. They are in mutually perpendicular. That resultant force is passing through the diagonal, that is FR. But third mass is there. This third mass also attract this one. So that force is acting in that direction along the diagonal. That force F dash. Why F dash it is? Because the distance between the masses is root 2a. It is not a, it is root 2a. That's why force is different. That different force को हम F dash से indicate किया. So now ये दोनों forces का resultant and F dash both are in the same direction. That's why net force is equals to Fr plus F dash लिखा. Fr plus F dash. Clear? So now Fr calculate किया by using this formula. Theta is 90 degrees. If theta is 90, cos 90 value 0 हो जाएगा. ये cancel out a term. Simple F square plus F square आ जाएगा. F square plus F square is 2F square. इसको root 2F लिख सकते हैं because F square comes out of the root, it becomes F. So Fr मिलेगा. Then F dash. F dash means force between these two masses. force between the two masses F dash equals to G into m square by distance is root 2a, so root 2a ka whole square. Then F net is equals to root 2 into gm square by a square plus and gm square by 2a square, that is F dash. दोनों ऐड किया, कॉमन लिया, then we got this final expression. Clear? So this is about this numerical, sir. Simple. So means application of Newton's universal law of gravitation is simple question, sir. So इसमें थोड़ा टफ करने के लिए for this like this questions comes in NEET में आ सकता है ये क्वेश्चंस, JEE में आ सकता है, और कुछ टफ करके और एक क्वेश्चन देगा आपको. दैट क्वेश्चन इज कम्स नेक्स्ट. यू सी द थर्ड क्वेश्चन. सोच को इधर सेम 4 particles each of mass m are equidistant from each other moving along a circle of radius capital R under the action of their mutual gravitational attraction. The speed of each particle is how much? Already in kinematics we are discussing in motion in a plane circular motion. Already we discussed circular motion. If any particle moving in a circular motion or that particle is moves along a curved path, so which force is acting on it towards the center? That force is centripetal force. ठीक है? So centripetal force. Here the question what they are given, they are moving along the circle of radius R under the action of mutual gravitational force. Mutual gravitational force. Under the action of mutual gravitational force. If these 4 particles rotating in a circle, they are rotating in a circle due to which force? Gravitational force. It means, what is the concept here? What is the logic? If they are moving in a circular motion, centripetal force is required. So that centripetal force, who provides that centripetal force? That centripetal force is provided by gravitational force of attraction between the particles. So that is the logic in this question, sir. Simply we can solve that. So simple, 4 particles, they are rotating in a circle. So if you can take a circle and you can arrange those 4 particles equidistance. These are the 4 particles. They are arranged in equidistance. ऐसे. So you consider any one of the particle. On that particle you calculate that gravitational force. Already we calculate this gravitational force, sir. Along this direction all particles are identical given. All particles are identical and this particle is attract this one in this direction. This particle is also attracted. So दोनों का बीच में angle 90 degrees. So that resultant force comes in this direction, that is F resultant. Third particle is also attracted this, that force is F dash. So already we calculate this net force. F net is equals to F resultant plus F dash. Already we calculate. फिर if you want you calculate, sir, directly हम लिख सकते हैं. So F net is equals to root 2F plus F dash. Directly लिख सकते हैं. Previous numerical, this one only we can. So root 2 into F. F is G m square by a square plus f dash is g m square by इधर से इधर तक distance already you know ना a root 2, so that is root 2a whole square. After simplification we can obtain g m square by a square is common, and within the bracket root 2 plus 1 by 2 आ जाएगा. This is the net force acting on this particle. ठीक है. This force provides that necessary centripetal force. So this net gravitational force provides necessary centripetal force. So this net gravitational force provides that necessary centripetal force. You know na? So what is the centripetal force formula? mv square by r. So F net मालूम है आपको. F centripetal force is कितना सर? m v square by r. R is the radius of the circle. So m v square by r. So हम centripetal force को net force equate कर सकते हैं. That is mv square by r is equals to g m square by a square into root 2 plus 1 by 2. 1 m is cancel out हो जाएगा. Then r is the radius of the circle. So radius of the circle is here to here. This distance is nothing but r. So r value कितना आ जाएगा? पूरा इधर से इधर तक डिस्टेंस इज a रूट 2. सो इसका आधा लेगा तो आपको a बाई रूट बाई 2 करो. सो a बाई रूट 2 आ जाएगा. सो r वैल्यू इज a बाई रूट 2 दैट इक्वल्स टू g m बाई a स्क्वायर root 2 plus 1 by 2. This root 2 goes to the top. So v square root 2 by a equals to gm by a square into root 2 plus 1 by 2. So इधर एक a कैंसिल root 2 नीचे आ जाएगा. So velocity v is equals to gm by a root 2 into this is 2 root 2 plus 1 by 2 स्क्वायर का रूट लिख सकते हैं ऐसे. ठीक है. So this is the velocity of that particle if it is rotating in a circular motion. ठीक है. Means थोड़ा मिक्सड कॉन्सेप्ट. डायरेक्ट फोर्स है तो डायरेक्ट बिट आ जाएगा, बट इधर फोर्स विथ सर्कुलर मोशन भी मिक्स किया. मीन्स दिस क्वेश्चन इज क्लबिंग क्वेश्चन. मीन्स 2 चैप्टर्स इंटरलिंक करके एक क्वेश्चन दिया. मीन्स इन कॉम्पिटिटिव एग्जाम्स they can provide the questions like this. Means 2-3 chapters mix करके they prepare the question. Then these type of questions are JEE mains के लिए आने के लिए chances है. So mixing किया. Already motion in a plane में circular motion पढ़ा. So वो circular motion लेके gravitational को mix करके एक question prepare करके आपको दिया. ठीक है. So means we expect like that questions in competitive exams. Straight away if they are given the questions means it is subject to exam. It is not a objective competitive exam. So competitive exams में we always expect in clubbing questions. 2-3 concepts mix करके एक question frame करने के लिए that paper setter सोचता है. That's why be serious in all the concepts. So if you learn thoroughly about the concepts, then definitely is numericals easily we can solve. Physics is dead easy if you know the concepts. You don't know about the concepts, directly we go for that solving of questions, solving of numericals means it is very difficult because how to open the question मालूम होना चाहिए. So here the concept is this one, circular motion बोला, and how they are mutual attraction में they घुमा. So इसलिए वो gravitational force provides that centripetal force. Circular motion means only centripetal force is there, so they provide that. So our idea is gravitational force कितना है, एक मास में कैलकुलेट किया, that force provides the necessary centripetal force. So I equate the two, then I got that final expression. ठीक है. So this is about third question, sir. If we go for next question, fourth question, this is the fourth question na? Next fifth question. Fifth question में see this fifth question, चलता नहीं है, ठीक है. You see this fifth question. In this fifth question थोड़ा टफ करके देता है. फॉर JEE एडवांस में ऐसे क्वेश्चंस आने के लिए चांस है. इफ JEE मेन क्वेश्चन इज, इफ इट इज वेरी टफ पेपर दिया मीन्स थोड़ा ऐसे क्वेश्चंस दे सकते हैं. ए पार्टिकल ऑफ मास m, इधर पार्टिकल ऑफ मास m इज देयर, situated at a distance d from one end of a rod of mass m and length l as shown in the figure. Find the magnitude of the gravitational force between them. अभी तक हम क्या डिस्कस किया, ए पॉइंट मास ले लो, ए पॉइंट मास ले लो, ये दोनों मास का बीच में डिस्टेंस r है, this force is m, this mass is m, then force equals to gm into m square by r square. ऐसे फार्मूला यूज करके कैलकुलेट किया. बट दिस इज नॉट पॉइंट मास, इट इज अ लीनियर बॉडी, सो कंटिन्यूअस डिस्ट्रीब्यूटेड मास बॉडी. So continuous distribution of mass is there. If you can take this end mass, distance is very less. This end mass, distance is more, d plus l हो जाएगा. So these type of bodies are called continuous distributed mass bodies. So in those situations, what we can do? How we calculate the force? So for that, we can select a small element. A small element. Due to that small element, we calculate the force. Due to the small element, we calculate the force. And thereafter, we can integrate that expression within the limits. We can integrate the expression within the limits. Then we can obtain that final expression between this body and this body. ठीक है? So for that small element, if you can take, you take this small element, sir. This is the small element of thickness, that is the length dx. Here first I calculate the mass of the small element. Mass of the small element is equals to mass per unit length. Capital M is the mass of the rod. Capital M is mass of the rod given. L is length of the rod. Mass per unit length, this is m by L. So for unit length में इतना मास है. For dx length में कितना आ जाएगा? dx into m by L. 1 chocolate is 1 rupee. 10 chocolates कितना है? 10 rupees. ऐसे unit mass, unit distance में mass m by L, and dx distance में कितना हो जाएगा? dx into m by L. This is the mass of that small element. Now we calculate the force between this small element mass and this mass. ये दोनों का बीच में force we calculate. So that force is small amount of force, that is G into point mass, this is small m, and element ka mass dm by distance between them is x, say x square. This is the force, you know na force formula, G m1 m2 by r square. So G into m into dm by x square. This is the force. Now हमको क्या चाहिए? This force further I write like this, df is equals to G into dm value I substitute here, m into dx by L into this small x square. This is the force between, due to this small element ka mass and this point mass. Between these two, the force is this is. But हमको क्या चाहिए? Total force between this rod and mass. ये दोनों का बीच में total force चाहिए. For calculation of total force, what we can do? We must do integrate the given expression. So we integrate this, integral of df equals to G small m capital M by L remains constant. Small m, capital G, capital L remains constant. So simple integral of 1 by x square dx. Integral of 1 by x square dx. So here limits चाहिए. This end is कितना दूर पे? D दूर पे. And this end is how much distance? D plus L, because either the variable is x. The variable is x. If the variable is x, so we can take the limits d to, this limit is d plus L. You know that integration formulas, basic classes में already given those integration formulas. So what is the formula? Integral of x to the power n dx. Basic maths में given this one. X to the power n plus 1 by n plus 1. This is the maths formula sir. In integration आ जाएगा. इसको हम कैसे लिख सकते हैं? इसको G small m capital M by L into integral x to the power minus 2 dx लिख सकते हैं ना. x square न्यूमरेटर में आ जाएगा तो minus 2 हो जाएगा. So this is a d and this is a d plus L limits. So G small m capital M by L. This one x to the power n place में 2 is there, plus 1 by n place में 2 plus 1, there is limits d to d plus L. This is the limits. Apply those limits. After simplification, हमको G small m capital M by L, this simplification is minus 2 plus 1. Minus 2 plus 1 gives x to the power minus 1. नीचे minus 1. Limits d to d plus L. ठीक है? So now minus बाहर रखो. G capital M small m by L into x to the power minus 1 को 1 by x लिख सकते हैं. 1 by x and you apply the limits d to d plus L. If you apply the limits d to d plus L, then what you can obtain? The final answer goes to f equals to minus G capital M small m by L into limits if you can apply 1 by d plus L minus 1 by d. So this is the force between this rod and this point mass. Is it clear? So force between the rod and the point mass is how much? If you want, you simplify it this one by taking LCM and you simplify it, then you got that final expression also. And sometimes they release up to this only, because ABC options में इतना ज़्यादा simplification नहीं हो जाएगा, direct दे सकता है ऐसे expression, means थोड़ा complicate कर सकता है. इन JEE में टफ पेपर है तो ऐसे आ जाएगा. एडवांस में सिंगल ऑप्शन क्वेश्चंस में ऐसे क्वेश्चंस दे कैन आस्क इन JEE एडवांस में क्वेश्चंस ऐसे आ जाएगा. मीन्स इफ यू हैव मोर मैथमेटिकल बैकग्राउंड then easily we can solve, because in advance, that is in JEE people, maths is there na, इसमें integration is there. If you have command on calculus part, then easily we can solve this direct. This x to the power minus 2 directly we know 1 by x. Integration is x to the power minus, that is minus 2 is minus 1 by x is the integration. We know, but we can solve. अभी आप क्लास 11 में है ना, you don't know about that what is integration. So what is the formula? So based on this formula we can solve, but in class 12 easily we can solve this by knowing that integration. ठीक है. So this is one of the questions are advanced level questions, means ऐसे questions होता है, इसमें भी tough कर सकते हैं. So that type of questions also there. So और एक question है, वो क्वेश्चन आई डिस्कस. ठीक है बच्चों, नोट किया ना. सो सिंपल ऐसे डिफरेंट एनी ऐसे कंटिन्यूस बॉडीज इफ दे आर गिवन, सिंपल टेक्निक इज we select a small element. Due to the small element we calculate the force, and by integrating that we can obtain the total force. This is only the technique for advanced level questions. ठीक है. So for today's these questions, this concept is over. So next class we discuss about that gravitational field and potential. That is also very important concept from gravitation, compulsory in NEET, JEE main and advanced, compulsory one question from gravitation chapters are easy. That questions very dead easy sir. So if we practice well, then easily we can solve. ठीक है. Thank you students. Next class we मिलेगा.